scalar triple product is equal to 0. That is, if the determinant value is equal to 0, then the vectors are said to be coplanar. If the scalar triple product is equal to 0, then the three vectors are said to be coplanar vectors. Coplanar is nothing but, as I told, if A dot B cross C is equal to 0, then the vectors are said to be coplanar. They are coplanar. For coplanarity, what is the condition? The box product of vectors A, B, C is equal to 0. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty of mathematics, Vidhyaashram PU College, the temple of excellence. Now in my previous class we have discussed regarding the problems, miscellaneous problems connecting to dot product and scalar product. So in this session I am going to discuss very important concept that is called the scalar triple product, or it is also called as the box product. Now let us discuss regarding the box product, or it is also called as the scalar triple product of three vectors, triple product. Now if A comma B comma C, if vector A, vector B and vector C are any three vectors, then the box product or scalar triple product of three vectors is denoted as box product A comma B comma C, or it is also equal to A dot B cross C. Suppose if, let us consider, if vector A is equal to A1i plus A2j plus A3k vector, and vector B, if vector B is equal to B1i plus B2j plus B3k vector, and vector C is equal to C1i plus C2j and plus C3k cap. So A, B, C are any three vectors where A is equal to A1i cap, A2 plus A3. Similarly, vector B is equal to B1 I cap plus B2 j cap plus B3 k cap, and vector C is equal to C1 I cap plus C2 j cap plus C3 k cap. Then the box product of these three vectors is denoted as A, B, C. This is called the box product, or this is also equal to, this can also be written as A dot B cross C. What is this A dot B cross C? This is nothing but the determinant, the coefficients of all the three vectors, coefficient of vector A, vector B and vector C. A dot B cross C, that is nothing but A1, A2, A3, B1, B2, B3 and C1, C2, C3. So the determinant of A1, A2, A3, B1, B2, B3 and C1, C2, C3 will give the box product or scalar triple product of three vectors. Now suppose if this A dot B cross C is equal to 0, if the scalar triple product is equal to 0, then the three vectors are said to be coplanar vectors. If A dot B cross C is equal to 0, then they are coplanar. This is equal to 0 implies the vectors are coplanar vector. And the geometrical meaning of this is the volume of a parallelepiped. To find the volume of a parallelepiped whose coterminous edges are A, B, C is given by A dot B cross C. The box product of A, B, C or A dot B cross C will also give the volume of a parallelepiped whose coterminous edges are vector A, vector B and vector C. This is very important concept. Now let us come to the problem. Now what are the problem? Let us discuss the problems. Now first one, find the scalar triple product of the vectors. Vector A is equal to I plus 2j cap minus 2k cap, and vector B is equal to 3i plus 2j plus 2k, and vector C is equal to 2i minus j cap plus k cap. Now what is the box product or scalar triple product? The scalar triple product is nothing but A, B, C, the box product of A, B, C, or it is also equal to A dot B cross C vector. Vector A dot B cross C. Now what is this equal to? This is nothing but coefficients of I, J and K from the vectors A, B, C. The coefficient of I, J, K in the vector A is 1, 2 and minus 2. For the second vector the coefficients are 3, 2 and 2, and for the third vector 2, minus 1 and plus 1. Now simplify, this is determinant again, expand with respect to first row. This is equal to 1 into this row and column is deleted, 2 ones are 2, minus into minus plus, 2 ones are 2, minus 2 into this row and column is deleted, 3 ones are 3, minus 2 twos are 4, 3 minus 4 plus minus 2 into This row column is deleted. 3 ones are 3. Minus 3 minus 4. So this is equal to 1 into 4 minus 2 into minus 1 minus 2 into minus 7. This is equal to 4 plus 2 plus 7 2s are 14. 14 plus 4 plus 2, that is nothing but 18. 14 plus 4, 18 plus 2 is 20. So the required answer for this is A dot B cross C is equal to 20. This is the required answer. See here, I will explain once again. So the box product or scalar triple product is nothing but A dot B cross C is equal to a determinant. The coefficients of I, j, k in the vector A is 1, 2, minus 1. And for the second vector B is 3, 2 and 2. And for the third vector, vector C is 2, minus 1 and 1. Simplify this. Expanding with respect to first row. So plus, minus and plus. This is gone. 1 into 2 ones are 2. Minus into minus plus 2. Minus 2 into delete the row and column containing 2. 3 ones are 3. Minus 2 twos are 4. Minus 2 into this row and column is deleted. 3 ones are 3. Minus 3. Minus 4. So 2 plus 2 is 4. Minus 2 into 3 minus 4 is minus 1. Minus 2 into minus 4 minus 3 is minus 7. 4 minus into minus plus 2 ones are 2. Minus into minus plus 7 2s are 14. 14 plus 4 is 18 plus 2 is 20. So the required answer is 80. So this is called a scalar triple product. That is why it is a scalar quantity. So you are going to get a scalar quantity. Scalar triple product is nothing but A dot B cross C is the value of that determinant. That's it. Now let us come to the next problem. Hope you followed. Same. So evaluate the box product. Again, this is nothing but a box product of three vectors, vector A, vector B and vector C. Now, so suppose if this is vector A, vector B and vector C, then this is equal to A dot B cross C. So this determinant, write down the coefficient of this 1, minus 1, plus 1 and the coefficient of this is 2, 1 and 1 and the coefficient of vector I, j, k in the vector C is 2, 1, 2. Okay. So this is vector A, this is vector B and this is vector C. Now simplify this. Plus, minus and plus. 1 into 1 2s are 2 minus 1. Minus into minus plus 1 into this is gone. 2 2s are 4 minus 2 plus 1 into row and column is deleted. 1 2s are 2 minus 2. So this is 1 into 1 plus 1 into 2 plus 1 into 0. This is 1 plus 2 is equal to 3. So the required answer is 3. That's it. Okay. See, I'll explain once again. This is nothing but the box product of ABC. The box product of vector ABC is A dot B cross C is equal to determinant. The coefficients of vector A, vector B and vector C. I, j, k coefficients in vector A, B, C. So the coefficient of I, j, k are 1, minus 1 and 1. For the second vector B it is 2, 1 and 1. For the third vector it is 2, 1 and 2. Simplify. Expand with respect to first row. 1 into 1 2s are 2 minus 1. Minus into minus plus 1 into 2 2s are 4 minus 2. Again plus 1 into this is gone. 1 2s are 2 minus 2. So this is 0. 2 minus 1 is 1. 1 into 4 minus 2 is 2. So 1 plus 2 is equal to 3 is the required answer. The box product or scalar product of this vector is nothing but 3. Okay. Now let us come to the next problem. Find the volume of a parallelepiped whose coterminous edges are vectors 2i plus j plus 3k and I minus I plus 2j plus k and 3i cap plus j cap plus 2k cap. So these are nothing but the vectors A. Now let vector A is equal to 2i cap plus j cap plus 3k cap and vector B is equal to minus I plus 2j cap plus k cap. Vector C is equal to 3i plus j plus 2k cap. Now what is the volume? Volume of a parallelepiped is always equal to A dot B cross C. This is the formula for volume. The volume of a parallelepiped is given by A dot B cross C. So therefore the volume of parallelepiped is equal to A dot B cross C. This is equal to, write down the coefficients. that is 2, 1 and 3 determinant, again minus 1, 2 and 1, and the coefficients of I, j, k cap in vector C is 3, 1 and 2. Expand, this is plus, minus and plus. So this is equal to 2 into 2 2s are 4 minus 1 into this row and column is deleted, 1 2s are 2 minus 3 1s are 3 plus 3 into this is gone, 1 1s are 1 minus 6. So this is equal to 2 into 3 minus 1 into minus 5 plus 3 into minus 7. 2 3s are 6, minus into minus plus, 1 5s are 5, minus 7 3s are 21. So this is equal to 6 plus 5 is 11, minus 21 is equal to 11 minus 21 is minus 10. The required volume, therefore the volume of the parallelepiped volume is equal to minus 10 cubic units. Minus 10 cubic units. The negative sign indicates the volume is decreasing. The volume is decreasing. So, to find the volume of a parallelepiped whose coterminous edges are A, B, C is given by A dot B cross C. That is nothing but the box product of the three vectors. So, here the required answer is minus 10 cubic units. Okay, negative sign indicates it is decreasing. The volume is decreasing. That's it. Now, let us come to the next problem. What is the problem? Show that the vectors, vector A is equal to I cap minus 2j cap plus 3k cap, and vector B is equal to minus 2i cap plus 3j cap minus 4k cap, and C is equal to I minus 3j cap plus 5k cap are coplanar. Coplanar is nothing but, as I told, if A dot B cross C is equal to 0, then the vectors are said to be coplanar. So, to prove the given three vectors are coplanar, show that the dot product, that is the box product A dot B cross C, scalar triple product is equal to 0. That is, if the determinant value is equal to 0, then the vectors are said to be coplanar. Let me solve this. So, to prove that the vectors are coplanar, A dot B cross C is equal to 0. The box product is equal to 0. Now, to prove that A dot B cross C is equal to 0. Now, that is, let us write down the dot product A dot B cross C. So, 1, minus 2 and 3. Then, for the second vector, it is minus 2, 3, minus 4 are the coefficient of I cap, k cap and j and k cap. For the third vector, it is 1, minus 3 and 5. Simplify. If this is equal to 0, then the three vectors are said to be coplanar vectors. Now, 1 into expand with respect to first row, 1 into 5 3s are 15, minus into minus plus, 3 4s are 12, minus into minus plus 2 into this row and column is deleted, 2 5s are 10 minus 2 5s are 10, that is minus 10 minus 1 4s are 4, minus into minus plus 4, again plus 3 into this row and column is deleted, 2 3s are 6, minus into minus plus 6 minus 1 3s are 3. 1 3s are 3. Now, this is equal to 1 into 15 minus 12 is 3, plus 2 into minus 10 plus 4 is minus 6, plus 3 into 6 minus 3 is equal to 3. Now, this is 3, 2 6 are 12, plus 3 3s are 9, 3 plus 9. 3 plus 9 is 12 minus 12 is equal to 0. So, A dot B cross is equal to 0. Therefore, the vectors, the vector A, comma B and C are coplanar vectors. A, B, C are coplanar vectors. Okay, hope you followed this. Very simple. So, what is to prove is to prove that A dot B cross C is equal to 0. Write down the determinant of A dot B cross C is determinant, the coefficients of I cap, j cap, k cap for the vectors A, B and C. So, we are going to get this expand. So, then this is equal to 12 minus 12 is equal to 0. If the determinant value is equal to 0 means then the vectors are said to be coplanar vectors. Okay, right. Now, let us come to the next problem. Now, this is very important problem. Now, you may expect this for 3 marks. Very important question it is. Now, what is to prove that? Prove that the box product of A plus B, comma B plus C vector, comma C plus A vector is always equal to 2 times the box product of A, B, C vector. So what is to prove? To prove that box product of A plus B, comma B plus C, comma C plus A is always equal to 2 times the box product of A, B, C. This is very important problem. Now let us take LHS. LHS. Write down the box product of this. What is given? A plus B, comma vector B plus C, comma vector C plus A. Now suppose if A capital, let us consider capital A, capital B, capital C are any 3 vectors, then the box product of these 3 vectors is given by vector A dot B cross C. Right. Suppose this is vector A, vector B, vector C. This can be written as A dot. A dot means A plus B vector dot B cross C. B cross C is nothing but vector B plus C cross product of this C plus A. So A plus B dot vector B plus C cross C plus A. Now let us simplify this. This is as it is, don't change this. A plus B dot, let us simplify this. Multiplied B cross C plus B cross A vector B cross vector A plus C cross C vector C into C vector plus C into vector A. Now since C cross C is always equal to 0, if 2 rows 2 columns are same, then the value of determinant is equal to 0. So this reduces to 0. This can be written as vector A plus B dot, this is same, B cross C plus B cross A plus this becomes 0 plus C cross A vector. Okay. Now let us simplify this. So hope you followed this much. This is very important step. See here, vector A plus B, comma vector B plus C, comma vector C plus A, box product is always equal to A dot B cross C. This is of the form A, B, C vector box product. A dot B cross C is nothing but A is A plus B dot B plus C cross C plus A. Simplify this product first. B into C, B cross C plus B cross A, C cross C plus C cross A. Since C cross C is equal to 0, then B cross C plus B cross A plus C cross A. Now I'll go to the next page. So in the next page we'll have this vector A plus B dot B cross C vector B cross C plus vector B cross A plus this is 0 gone, C cross A vector C cross A. Now this is equal to, now you can apply the dot product for this. So A dot B cross C plus A dot B cross A plus A dot C cross A plus again similarly apply B dot B cross C plus B dot B cross A plus B dot C cross C. This is very important step. Okay, now just A dot B cross C plus B cross A plus C cross A, similarly plus B dot all these 3 vectors, B dot B cross C plus B dot B cross A plus B dot C cross A. So if any 2 vectors are same, so that is, if it is like this, A dot B cross A, if any 2 vectors are same, then the value of this determinant is equal to 0. That means if 2 rows 2 columns are same, then the value of a determinant is 0. So A dot B cross A is equal to 0. Similarly A dot C cross A is equal to 0. So this can be written as A dot B cross C as it is plus A dot B cross A is 0 plus A dot C cross A is also equal to 0 plus B dot B cross C is also equal to 0. B dot B cross A is also equal to 0 plus this is B dot C cross A as it is. Now this can be written as, what is A dot B cross C? This is nothing but the box product of A, B, C plus again B dot C cross A is again nothing but the box product of the vectors A, B, C. So how many box products are there? 2 box products. So therefore this is equal to vector 2 times the box product of A, B, C. This is the required RHS. That's it. Very simple. Okay. Very important and very simple problem for 3 marks. So apply dot for all the 3 vectors, A dot, these 3 vectors, plus B dot, all the 3 vectors. So then A dot B cross C is same, and the remaining, if 2 vectors are same, then the value of the determinant is 0. If 2 rows, 2 columns are same, means then the value of a determinant is 0. So this is 0 plus 0, 0 plus 0, and B dot C cross A, box product of vector A, B, C, and the box product of vector A, B, C is equal to 2 times the box product of vector A, B, C. So therefore, the box product of vector A plus B, comma vector B plus C, comma vector C plus A is always equal to 2 times the box product of vector A, B, C. That is the scalar triple product. Okay, hope you followed this. Very important problem. Now let us come to the next similar type problem. One more problem is there. So that is, prove that vector A comma vector B comma vector C plus D is equal to the box product of A, B, C plus box product of A, B, D. Now let us take LHS. What is given? LHS. LHS is equal to box product of vector A comma vector B comma vector C plus vector D. Again, this is nothing but the box product of ABC. Box product of ABC is nothing but A dot B cross C. Vector A dot B cross C. So this can be written as vector A dot B cross C. B cross C vector is nothing but C plus D. Okay. Now this is A dot. Simplify this. B cross C plus B cross D. Now apply the dot product for these two. This can be written as A dot B cross C vector plus A dot B cross D vector. Now what is this equal to? So this is A dot B cross C. A dot B cross C is nothing but the box product of the vector ABC, vector A, B, C. Plus similarly, A dot B cross D is nothing but the box product of the vector A, B and vector D. This is the required RHS. That's it. Very simple. Okay. See here. LHS, A, vector A, comma, vector B, comma, vector C plus D, box product of A, B and C plus D is nothing but A dot B cross C. A dot B cross C means B cross C plus D. Multiply this B cross C plus B cross D. Apply the dot product for this A dot B cross C plus A dot B cross D. Now A dot B cross C is nothing but the box product of A, B, C. Similarly, A dot B cross D is nothing but the box product of A, B, D. So what is required to find is box product of A, B, C plus box product of A, B, D. That is the required RHS. Okay. These two problems are very, very important for the point of examination. Hope you followed. Now, let us come to the next problem. What is the next problem? This is also a very important problem. Find X such the 4 points A, B, C, D are coplanar. So you are going to study the same type of problem in 3D geometry. You are going to study the same problem, whereas in vectors, let me see how we are going to solve. What are the points given? A, B, C, D are given. The 4 points are given. So since they are coplanar, what is the condition for coplanar? The box product of 3 vectors are 0. So here just find out the box product of vector AB, vector AC, comma vector AD. Equate this to 0. If box product of AB, comma AC, comma AD is equal to 0, then solve it, you will get the value of X. That's it. Okay. Now let us find out the position vector of AB, then AC and AD. Now the position vector of vector AB, position vector of AB is equal to OB minus OA vector. So therefore vector AB is equal to OB. OB direct, if you want you can straight away write 4 minus 3 into I plus X minus 2 into J plus 5 minus 1 into K. So this is equal to vector AB is equal to 4 minus 3 is 1 plus this is same X minus 2 into J, 5 minus 1 is 4K. This is vector AB. Similarly, vector AC. vector AC is equal to OC minus OA vector, this vector OC minus OA vector. So 4 minus 3 into I plus 2 minus 2 into J plus minus 2 minus 1 into K cap. So this is nothing but 4 minus 3 is 1I plus 2 minus 2 is 0J minus 2 minus 1 is minus 3K cap. Similarly, find out the vector AD and find out the box product for vector AB, AC and AD equate to 0, you will get the answer. That's it. Let us find out vector AD. Vector AD is equal to OD vector minus OA vector. So this minus this vector, this minus this vector. Now this is equal to OD. OD is 6 minus 3 into I plus 5 minus 2 into J plus minus 1 into K. So this can be written as vector AD is equal to 6 minus 3 is 3I, 5 minus 2 is 3J minus 2K. This is AD. 3I plus 3J minus 2K. Now find out the box product. I will rub this and I will do again. Now the box product of vector AB, comma AC, comma vector AD is equal to 0. That is box here AB, this is AB, AC and AD. What is AB? I plus x minus 2j cap plus 4k cap. AC is I plus 0j minus 3k cap and AD is equal to 3I plus 3j minus 2. So coefficient of I, j, k 1 and x minus 2 and 4. Okay. Now for the second vector 1 0 1 0 minus 3 and for the third vector it is 3 3 and minus 2 is equal to 0. Simplify this, you will get the answer. That's it. So coefficient of I, comma I, j, k cap in the first vector is 1 x minus 2 4. For the second vector is 1 0 minus 3 and for the third vector 3 3 and minus 2. Now let us simplify this. Plus minus and plus. That is 1 into this row column is deleted 0 minus into minus plus 3 3s are 9 minus x minus 2 into this row and column is deleted 1 2s are 2 minus 2 minus into minus plus 3 3s are 9 plus 4 into this row and column is gone 1 3s are 3 minus 0 is equal to 0. Now that is 1 into 9 minus x minus 2 into 9 minus 2 is 7 plus 4 into 3 minus 0 is 3. Now simplify this and solve for x, you will get the answer. So this is 9 minus 7x minus into minus plus 7 2s are 14 plus 4 3s are 12 is equal to 0. Now what is this equal to? 9 1s are 9 minus 7 into x is 7x minus into minus plus 2 7s are 14 plus 4 3s are 12. Now add this. So 14 plus 12 plus 9. 14 plus 12 plus 9 that is equal to 35. So this is 35 minus 7x is equal to 0. 35 minus 7x is equal to 0. 35 minus 7x is equal to 0. 35 minus 7x is equal to 0 implies 7x is equal to 35. Therefore, x is equal to 35 divided by 7 means this is equal to 5. So therefore, x is equal to 5. So the value of x is equal to 5. For x is equal to 5, the vectors, the 4 points A, B, C, D are coplanar. This is very important problem. You may expect this also for 3 marks. Okay, right. Now let us come to the next problem. Find the sum of the vectors, vector A, B, C and also the magnitude. Addition of 3 vectors. That's it. Now here, write down the solution. Vector A plus B plus C vectors. What is vector A? I minus 2j plus k vector plus vector B is minus 2I plus 4j plus 5k vector and vector C. C is equal to I minus 6j minus 7k. This is nothing but addition of vectors. This is I minus 2j plus k minus 2i plus 4j plus 5k plus I minus 6j minus 7k. I values I minus 2i plus I plus I is 2i minus 2i is 0i. I plus I is 2i minus 2i is equal to 0i. J terms 2j minus 2j plus 4j is plus 2j minus 6j. So here what we have, minus 2j minus 6j is minus 8j plus 4j is minus 4j. Then k terms plus k plus 5k is 6k minus 7k is minus 1k. That's it. So here just add the coefficients of I, j and k. Coefficient of I is 1, here minus 2, here it is plus 1. 1 plus 1 is 2, minus 2 is 0. Again coefficient of j is minus 2, again here it is 4 and it is minus 6. Minus 6 minus 2 is minus 8 plus 4 is minus 4. Again k coefficient is 1 plus 5 is 6 minus 7 is minus 1. So this is the value of vector A plus B plus C. Now to find the magnitude, length of A plus B plus C, the magnitude of A plus B plus C is equal to square root of 0 square is 0, 4 square is 16 plus 1 square is 1. This is equal to root 17. The magnitude of A plus B plus C is root 17. For the given vector, the magnitude is root 17. Okay, hope you followed. Now let us come to the next problem. Find the unit vector in the direction of PQ, where P and Q are the points. P is equal to 1, 2, 6 and Q is equal to 4, 5, 6 respectively. Now what is given vector? Write down the position vector. So the position vector of P and Q are vector OP is equal to I plus 2j plus 6k and vector OQ is equal to 4i plus 5j plus 6k cap. Now what is required to find is vector PQ is equal to vector OQ minus vector OP. Just subtract this. Vector 4i plus 5j plus 6k minus I minus 2j minus 6k cap. So this is equal to 4 minus 1 is 3i cap, 5 minus 2 is plus 3j cap, plus 6 minus 6 gets cancelled, this is 0k cap. Now find out the magnitude. Magnitude of vector PQ is equal to square root of 3 square is 9 plus 9, this is root 18. 18 can be written as 9 into 2, this is 3 root 2. So therefore unit vector in the direction of PQ along vector PQ is equal to vector PQ divided by its own length. Vector PQ divided by its own length. What is PQ? That is 3i plus 3j divided by its own length is 3 times root 2 vector. Term by term divide it, he will get the answer. That's it. So this can also be written as, therefore this is equal to, divide it. You can take 3 common factor, 3 out. So in the numerator I plus j divided by 3 root 2, 3 gets cancelled. This is equal to 1 by root 2 I plus 1 by root 2 j. This is the required answer. So the unit vector along the direction of vector PQ is 1 by root 2i plus 1 by root 2j. First find out the position vector of PQ. That's all. Position vector of PQ is OQ minus OP vector. So that is equal to 3i plus 3j plus 0k. Find out the magnitude of PQ. Square root of 9 plus 9, 18. That is 3 root 2. The unit vector along the vector PQ is vector PQ divided by length of vector PQ. So 3 common factor I plus j by 3 root 2, 3 gets cancelled. 1 by root 2 I plus 1 by root 2 j is the required answer. That's it. That's all regarding this problem. Now let us come to the next problem. So this is evaluate 3a minus 5b dot 2a plus 7b. This is the given. What is the given equation? Given vector 3a minus 5 times vector b. This is dot product of vector 3a plus 7b. So this can be simplified. This 3 into 3a dot 2a again plus 3a dot 7b minus 5b dot 2a minus into plus minus 5 times vector b dot 7b. So this can be written as 3 2s are 6 a dot a plus 7 3s are 21 a dot b minus 5 2s are 10 b dot a minus 7 5s are 35 b dot b. Since a dot a can also be written as length of a into length of a is length of a whole square. So this is 6 times length of a whole square plus 21 times a dot b, and b dot a is also equal to a dot b because dot product is commutative, minus 10 times a dot b. This is minus 35 times b dot b into b dot b is length of b square. So this can be written as 6 times length of vector a square, 21 minus 10 is plus 11 times a dot b vector minus 35 times length of vector b square. So the required answer is 6 into length of vector a square plus 11 times vector a dot b minus 35 times length of vector b square. This is 35 times length of vector b square. This is the required answer. That's it. Hope you followed. Listen to me. Multiply 3 2s are 6 a dot a, 3 7s are 21 a dot b minus 5 2s are 10 b dot a minus into plus minus 5 7s are 35 b dot b. So a dot a is nothing but the length of a square, and a dot b as it is, b dot a is also equal to a dot b. This is dot product, b dot b is equal to length of b square, 6 times a square plus 11 a dot b minus 35 times b length of b square. That's it. Okay, that's all regarding today's session. Let us meet with the next chapter in the next session, that is regarding the vector algebra is concerned. Thank you very much.